Okay, welcome back to the second video here in the 6th, 7th grade computer science professional development, where we're going to look at kind of the second section of that whole activity that we're doing. This is task 1. We're going to do some blink commands and add some stuff to our circuit. Where I've come back to is where you might be after you finish the first one, where you see I'm still on my home page here in Tinkercad. I'm logged in to essentially, I'm emulating a student account, and we'll look at that a little bit later, maybe when we're all together, is what I've got. If I'm under circuits, I can see last time I copied that, and if I open that, it'll take me back to what I was working on for task 0. But that's not what I want to do right now. I want to work on task 1. So once again, I'm going to come up and search for the template. Search the word Broncos. I want to grab task 1. That was created by me. Copy and tinker. Wait for it to load. And then once again, I'm back to kind of my original screen. It's the same circuit we were working with last time, but we're going to do a little bit different thing this time. So the first thing we're going to do, we're not going to actually open up the code window because we're going to change some stuff and look at our circuit. So first thing, let's look at kind of what we're looking at here is we've got a circuit, it's got a bunch of LEDs. What pins are the connected LEDs plugged into? Well, green, we can follow it out. It's going to be to 13. I'm going to take note of that. Blue, it's under 12. Red, it's on 11. So I'm going to write all those down. Is there anything else connected to the Arduino? Well, let's find out. There is this one black wire connected to GND all the way over here. So, one black wire connected to GND. It's a really important wire, and it kind of describes that in a second. What it is, it's really important. It's for a ground wire, and if you know anything about circuits and electricity, without that, our circuit wouldn't be complete, and my LEDs will never turn on. And what we're going to kind of look at now is anything using the list of basic components. Those are these over here that kind of populate. What are the objects? Figure out what are the objects between the Arduino and the LED. So like obviously if I'm looking, I got my Arduino here. I got a wire, so I guess I could talk about the fact that there's a wire. It's not in my list. Really what we're looking at is these guys right here. If I click on them, it highlights them, doesn't really tell me what it is. It's kind of sad. But if I look over here, it's a resistor, and it's also a pretty critical component to my circuit. And we're not going to talk very deeply as to what exactly they do, but it's important for students to know they exist, so that way when they're building and adding LEDs to the circuit, they remember to add those as well. Because if you do this with real LEDs and real Arduinos, the resistors are going to be incredibly important. That's what's going to keep you from burning out your LEDs. Here in the simulator, it'll just throw up a little error and say, hey, this did actually cause a problem. But it won't break anything because it's all virtual. But it's good to emulate those good practices as well. And so, kind of important to have those. It says if you don't have them, you'd burn them up. What we want to look at now is look really carefully what are these LEDs doing. I want to add another LED to the circuit. And so the one we want is going to be set up just like the other three. We're going to need a couple things. We're going to need wires. We're going to need a resistor, an LED, and another wire coming back. So let's look at some stuff. Here in Tinkercad, what we can do is look at the label and kind of see some components of our LEDs. So if I look and kind of zoom in on this LED, it's got its two legs. I can actually highlight over both of them, and it's going to tell me which one the cathode and which one the anode is. And that's really important because an LED is sensitive to the direction of electricity running through it. Also another way to burn up an LED. Again, fortunately, you can't do that in Tinkercad. So in real life, though, you would absolutely run the risk of frying an LED if you wire it backwards. So when I'm going to look, using Tinkercad, labeled the two legs, this LED on the right. Well, when I looked at this one, the one on the left, the straight one is the cathode, the bent one is the anode. So there is in fact the text box here. And that one's the anode. And then, if we look closely, we're going to look at a resistor. It's got several colored bands on us, and they kind of tell us about the strength. We're not going to go into what those strengths mean, but enough to recognize that the ones I have are all the same. And mine are red, black, brown, and there is also a gold band. And what this means is I've got a 200 ohm resistance on this resistor, so when I get a new one, I'm going to want to make sure it's the exact same. just so all of my LEDs are going to light up to the same level of brightness, because I like things to be uniform. What I'm going to have to do next, you can either follow along with me and follow along with the document. It's going to break down how you pull out an LED and build a circuit. You can also watch what I'm going to do. So if you'd had the code window open, you wouldn't be able to get to any of your components, so you'd want to make sure that's closed. We're going to want an LED, so I'm going to go ahead and click one of those first. And when I click on it, drag my mouse out, it appears. I'm going to go ahead and just drop it here right now. This little window's going to show up. Again, you don't have to change the color of the LED from red, but for me, I already have a red LED. So I'm going to change it and I'll make it orange, because why not? Next thing, if I were to just drag this onto my breadboard, I would have a problem building my circuit, because breadboards don't quite work that way. All of these, you can see how they're all highlighting in green when I highlight over them. They're all sharing kind of metal underneath the backing, if you weren't aware of how a breadboard works. And so if I put it there, they're going to be on the same circuit. Electricity won't flow through my LED. I'm going to want to rotate it just like all the others. And up here, I've got a rotate button. I'm going to spin it around. It's going to make it like all the others. And again, I like my sense of order, so I'm going to put it in nice equal spacing from all the others. Not at all something that really matters. It just makes it look pretty. So what you'd want to do next, if you're following along, you can kind of see here, what do I need? I needed a resistor. So I'm going to also do the same thing, click it, drag it out, let go of it. I'm going to want to rotate it so it fits. Now the important thing here is you're going to notice this is not the same color coding as the other resistors. And that's why we did the thing up above, noticing that, in fact, there's a specific pattern. I'm going to change this to units, over to ohms, and I'm going to type in 200 because that's what the others were. And the really critical thing from before, or from what we're going to do, is where this plugs in to the board, because we want our second terminal here on the same line as our LED, and we want this left-hand terminal to not be on anything, because if I put it here, this side is actually now connected to my ground, which means it's on the wrong side of the circuit, and if I pull electricity out of my next port, it's not actually going to go to the LED. So I'm going to want to make sure I'm building my circuit here. That's just something you got to be really careful with in the simulator. If you were building this with a real Arduino, in some ways it's much easier. You can bend these a lot more. I'm limited to a certain number of angles that these can be flexed to in your rotation. But now I've got an LED, or a resistor, excuse me. And then what I can do is, if I wanted to be really lazy and not care about how pretty things were, I can just take it from the end. I clicked on the terminal at the side of the resistor, take it to this Arduino and say, I'm done. It works perfectly fine that way. If you've noticed how I set up the rest of my circuits though, I like some sense of order and I like things to look pretty. So I'm going to bend mine just so it looks kind of nice like everything else. Not at all a requirement, just something I do because I like to do it. I have a little bit of some OCD tendencies. And what also generally I like to do is, in this case, it's an orange LED. I'm going to use an orange wire. Now note I didn't use a red wire with the red LED because red in wiring conventions generally is the hot side of a circuit. It's power. Not necessarily what I'm going to use to go with my red LED. Also doesn't matter. In this case, virtual electrons in the circuit don't care what color my insulation is. Neither do they care in real life. But I care because it helps me know which wire goes to where without having to follow them as easily. Keeps everything color coded. And so something to pay attention is to, what port did you plug it into? I plugged it into 10 because it's the next available one and it seemed as good as any. Fun fact, it doesn't matter. I can put it in any of them as long as I program it to go in the same, the corresponding number. Again, I'm going to put it in the next one just because that makes sense to me. Last thing I need to do is I got to finish my circuit. If you notice, all these other ones have a short black wire coming from the cathode going to this long section of my breadboard. What that's going to do is going to finish circuit. This one I am going to change to black, and I would encourage you to have students also change to black because this is the ground side of our circuit. We're completing it, and that's just so I know kind of at a glance what that's for. It helps me when I look at a circuit understand much more quickly what's going on. We're done building, so now it's time to do some code. So I'm going to pull my window open. what I've got in this case, what I left for my students, you're kind of seeing a little bit of is just a rehash of what they need to be doing. You know, what were their goals, and there's going to be a video example sometimes of what the output is supposed to look like, so that way they have something to reference to when they hit play. They can say if it does what it's supposed to or not, just by matching to the video. So, there's already some code provided for me. Cool. I'm going to use that as a starting point. Let's run it and see what happens. Kind of like last time, where we're starting, we've got a blinking green LED. Okay. Green LED blinks. So, I want to blink all of them, though, at the same time. I want the green, the blue, the red, and the orange all to blink on, and then all to blink off, all at the same time. So what I'm going to do in the setup section of the code, if we remember from the last video and the last task, I need to set up each of my LEDs. So I need not just 13, but 12, 11, and 10 as well. Copy and paste is my best friend, because I am lazy and do not want to type all of that. It's the exact same, just with different numbers. So now that means all of these ports are set up to be outputs. Why do we have to do this? Well, because they can be inputs. And if you get into later and more complicated Arduino circuits, you're going to want to have a mix. And so you need that choice. For the most part right now, though, we're going to be working primarily with outputs. So we got to think about what it means to blink all these LEDs simultaneously. I want the green, the blue, red, and orange all to turn on, and then them all to turn off. So what does that even mean? So let's think about it. Place the terms in the following order. I've already done it for you right here. What you'd have to do is all the LEDs, in this case, we're going to want to turn them on. We're going to wait. Then we want them all to turn off, and then we're going to wait again. And I'll show you why that's really important, why you wait again at the end. So let's expand out and kind of define what does it mean by all these LEDs turn on. So if we remember from task 0, what's the command to turn on the LED on pin 13? Well, either I remember it, or I can look at my code because my green LED turns on. I've got digital write 13 high. So I know that's how I turn things on. So I'll copy and paste that there. And if I wanted to turn on pin 12, well, it's digital write 12 high. So kind of want to think about in our pseudocode up here is kind of what we're done. It means kind of using words as code. You couldn't just copy and paste it into a program, but it helps you kind of understand maybe what you should be doing. I think the phrase all LEDs turn on is a box that has all these turn on commands. So in our code, we're going to want to write all these turn on commands before that first delay. And we provided you, this is exactly what it should look like. So if you really want to, you can copy and paste all the missing code and drop it straight into your program. Now, what you'll notice, things went a little funny on the formatting. What I talked about in the last video, white space does not matter. I could run it just like this, and it won't bother the computer at all. It bothers me a lot. It should bother you a lot, because when students start doing this, their code gets very messy, and it's very hard to tell what's going on. In a program like this, it's very simple, and you could probably figure it out, but code won't always be this simple. So after a while, you're going to want to make sure they're following the conventions, and that includes indentation. Now, if you notice here in Tinkercad, if I use tab, it doesn't line up. So what they're using is 2 spaces. The easiest way to get the correct spacing, though, is to just backspace it and hit enter, and it'll put it in the right indentation. Don't need to get rid of this white space, but I'm going to go ahead and do it anyway. And then what do I have left? I need to turn everything off. So think of the phrase all LEDs turn off as a box, and write all of the turn off commands between the 2 delays. So that means somewhere between here and here in this space. I did not provide the code because hopefully they can kind of learn by example. We've got digital write 13 low. I need to turn everything else off. Probably can figure out a similar way to do it. You could copy and paste this command if you wanted to, and then change your number. You could also copy and paste these commands up here, the ones that turn them on, and then just change the word high to low. In the end, I get to the same place, and I didn't have to type the word digital write, parentheses, 10, comma, space, low, parentheses, semicolon, over and over again. It's all about copy and pasting until you know what to do so you don't have to copy and paste. So, question here, run your program. Did it work? It did work. In this case, I know what I'm doing. Something common that people might do. In this case, why do we have to have this second delay? I provided it for you, so that way we don't run into issues. But if I got rid of that, how I did that is I just used a single line comment. It means it's just going to skip that. What will happen? They've turned on, and they don't turn off. They're still not turning off. Well, that's sad. I programmed to turn off. What's happening is, of course, an Arduino on a computer runs much faster than you and I can perceive. So it's going through this loop section. It's going to say turn them on, wait a second, turn them off, and then the loop is over. And when it reaches the bottom of this loop, line 37, it goes immediately back up to the top of the loop, line 27, turns them all back on again. So technically, they are being turned off. It's just what's happening is it happens so fast, there's no delay. It's as fast as the Arduino is processing this code, you will never notice it. So it's really important to have that in there. That's why in a program like this, I went ahead and already had it there. It solves you a few problems. And again, if you were to say skip and didn't do everything on your turn off, well, some of them are going to blink and some of them are going to turn on, and since you never turn them to turn off, they're just going to stay on. I'm going to put those back though. So the things to kind of think about as we reach the end of this program is, why do you think all the LEDs turn on together, even though there isn't code to turn them all on at once? Is essentially what I just talked about with why we need this delay command. Is if we follow down digital bright 13, 12, 11, 10, all high, it runs 13 first, then 12, then 11, then 10. But again, the Arduino and computer runs so much faster than we can perceive. We interpret that all being turned on at once. Same thing with them turning off. It happens so fast, we would never know it. That it technically, if you want to get into semantics, isn't happening all at the same time. And this last question is just kind of get students thinking about, as you go further into a unit over Arduinos, is like, do you think all these lines of code are unique? Or do you perceive that there's a lot of repetition? Hopefully most people recognize that there's a lot of repetition. I use copy and paste a lot. Digital write gets used all the time. These 4 groups of code, it's all the same, just with different numbers. Later on, I'm going to kind of exploit that fact to do some cool stuff. And that is the end of this particular video. And what we'll do afterwards is, what you can do is hop on over to the task 2 video, and that'll be the last one for the computer science professional development for 6th and 7th grade. There are additional videos you'll be able to find if you're interested in looking at some of the ones that were done for the 8th grade and just further Arduino based activities.